Hi, this is Dr. Melissa Shotell, also known as the AlignerBee, and I am here at IDS 2025 in Cologne, Germany, and I've made my way to the 3D Systems booth to check out all the new technology and innovation. And I've invited Stijn to join me today so that we could talk about the new technology that they are unveiling here. So this new piece of technology is referred to as nonlinear 3D printing. And in the orthodontic space, I think we could have a really interesting conversation about the future applications. So Stijn, thank you for joining me today.
Thanks for being here. It's a pleasure to have you, Dr. Shotell.
Thank you. Let's talk a little bit about what you have here at 3D Systems. So if you could explain the concept of nonlinear 3D printing to
Absolutely,
me.
it's a pleasure. So as we all know, the 3D printing technology these days has all been about linear movement. So we are pulling the printed part out of the resin in a vertical manner, so in a linear way, or SLA original concept, we are going top down into the bed. Now, everything in a patient's mouth or everything that we are making is an arch shape. And there are many benefits if we could print like this in a rotational way, non-linear way. So as you can see in the concept right here, which is just a proof of concept, it's a prototype where we are showcasing that if you print, instead of pulling it out linearly, directly out of the resin, but in a rotational way, that you have many benefits from an arch-shaped form.
Excellent. So if I'm looking at this correctly, is this area here the build platform?
Exactly.
And how would we start this process?
So you're absolutely right. So there is a very small build platform that actually rotates all the way into the resin, onto the membrane. It's a membrane technology. We can also make it upside down in a vat. But this small build platform is actually where we start the print, and you can see the supports here are very tiny and only on one side of the arch. So slowly, step by step, we are 3D printing and pulling and actually bending this night guard in this case out of the resin until this final result. Now you can clearly see the immediate benefit of almost no supports.
Excellent. So if I'm looking at this, I want to see here, this is our mechanical portion that's controlling, that's starting on this side of the vat and is then rotating out.
Exactly. Projected from the bottom, just like on the Figure 4 technology, projected to the membrane, onto this small little area here, that we only need a small area. We can fit up to maybe 2-3 night guards into this setup. Like I said, it's just a prototype, it's an idea. So that we are printing two, in this case just one, but maybe up to 2-3 night guards with the smallest cross section possible, and that's kind of part of the whole idea. What is slowing down or what is possibly creating problems while we are 3D printing is actually the area of the cross section that we are illuminating. That is also constantly changing. If we look at a night guard, and we look at the orientation that we are today printing on a DLP like the Nextend 5100, we are oriented like this. So the cross sections on this level compared to higher up, where you only have these two areas, is completely different. And that plays a role into the speed of the printing, but also the layer, the stepped approach of 3D printing has a negative impact. And of course, as you can see, all the support pins that you need to remove, that you need to manually grind away, polish the night guard, and all this goes away when using nonlinear printing technology.
So you mentioned the layers and the step layers as you're printing. I know with linear printing, many of us are used to 50 microns or 100 microns of printing. Approximately what is the layer thickness here?
Well, it is actually difficult to really give it a layer thickness because it's a rotational movement. So the actual movement, how much it comes out of the resin, is depending on the distance from the axis, the rotational axis, to where we are projecting. So you can imagine that the platform goes down, we start in one area, but while the night guard is coming out of it, it actually moves through here, further away from the axis, and that is the secret sauce, I would say, in our 3D systems development, is how to control that, how to do the slicing of the file in a rotational way. That's one part of the problem that we have solved. Now, Again, the advantage of doing that is that you don't have any layers into the surface. You are always curing the smallest cross section of the part, and with this you actually arrive to a glossy end result that you don't need to polish anymore. It's one of the major benefits from this technology.
So really, with this new concept in 3D printing, we're seeing the enhanced surface finish.
Absolutely.
And we're seeing a tremendous reduction in the supports.
Exactly.
So really, even if we were looking at the printing time, we also can account for a reduction in post-processing time.
100%. We are currently all about removing or minimizing the manual labor. It's important to all of us, especially if you think about share-side solutions. So you take your scan, your digital impression of the patient. You can have AI design or even design it in-house with an in-house technician. You can have your night guard designed in no time. You bring it to this printer. We will, at this moment, are printing this full night guard in 42 minutes. But even more important, after that, we just bring this to a nitrogen or a low oxygen curing chamber, a high power curing chamber that is on the market today already. We'll combine with this system. We did on this part, we did a power cure. The cure itself was 1.5 minutes. Takes about 3 minutes to remove the oxygen from the chamber, so a total of 5 minutes later, you have this night guard the way you have it in your hand now. There is no manual labor involved. You only need to remove that little support there at the distal area, and you can place it in a patient's mouth. Isn't that amazing?
That is. This is really a different way of looking at 3D printing. So we're seeing the paradigm shift from linear printing to non-linear, more rotational, to match the contours of our appliances. So I'm really excited to see where this is going to go in the future, especially as we look at the clear liner space, retainers, night guards. I'm curious to see in the future how we can really utilize a new technology of this type to help with our printing speeds, but also our post-processing, and even looking at the strength of materials.
Absolutely.
In the future. So I think we're going to continue to have a lot of conversations about this. Thank you so much for sharing this with me. Congratulations on your proof of concept in this new area. For more information on 3D printing, make sure to follow me on Facebook and Instagram at AlignerBee. So thank you so much.
Thank you, Dr. Shotell.